Hey guys, so yeah, we are going to discuss the Leetcode contest 328. Around 25 minutes are still left in the contest. Yep. So definitely my worst, my best performance till date. I actually have a rank 142 right now. I hope it doesn't goes below 200. We'll see about that. So yeah, let's get started. So let's start with the very first question. That is the difference between element sum and digit sum. So the problem states that you are given a positive integer array nums. The element sum is the sum of all the elements in nums. The digit sum is the sum of all the digits, not necessarily the distinct digits that appear in nums. And at the end, we have to return the absolute difference. By what you mean by absolute difference is that even if the difference is negative, you'll have to return positive. The absolute difference of element sum and digit sum. So then they have given example. So in example 1, the nums is 1, 15, 6, 3. So they have added it up. So 1 plus 15 plus 6 plus 3 is 25. And then if you add all the digits, so the digits are 1 plus 1 plus 5 plus 6 plus 3. So over there, like if you do that, you'll get 16. So you'll have to return 25 minus 16, that is 9. Then we have example 2. Over here the sum is coming out to be 0. So yeah, I actually did something wrong over here. It was an easy question, but still I didn't read the question properly and I did a different thing altogether. So I'm gonna show you the best way to do it or an easier way to do it. So when you're coding in a contest, the solution you should be writing should be concise or something that is pretty intuitive to you. It comes to you like as soon as you are able to think of it, you are able to code that up. So this is what I've coded over here. What I'm doing is I'm using a function called accumulate. So accumulate actually gives me the sum of all the elements from nums.begin to nums.end, and the initial sum is 0. And then I'm using a es. So by es I mean the element sum. Then I'm iterating over all the elements. I'm converting the elements to a string. Now why I'm converting the elements to a string? Because I want to check the sum of the digits itself, right? And it's easier for me to calculate the sum of individual digits if I have a string instead of a number. Then I'm initializing a variable s to 0, and then I'm calculating the sum of all the individual digits in it. Then I'm adding that sum or the local sum into this. I can actually improve it by simply doing this. Even this is valid, and this also saves me some time. So yeah, cool. So es plus is equal to sum of all the digits, and then at the end I'm returning the absolute difference between sum and es. So let's talk about problem 2. So problem 2 wasn't that tough. Had they given us even more tight constraints, then it could have become a bit tough. But the constraints were such that order of n into q, that is query length, would pass. So let's say they had given us constraints over here that n was let's say less than or equal to 1000, right? Or maybe 10 to power 4, let's say. In that case I wouldn't have been able to use this logic. It would have given a TLE, but over here n was just 500. Let me show you with an example itself so that it makes more sense. Give me a second. Yeah, okay, so the thing is that this is a matrix of n into n, and what the problem is asking me to do is that they will give me queries. Each query would be of size 4. In each query they will be giving me 4 values, that would be x, y, x1, y1, x2, y2, right? So what I have to do is that starting at the, I have to consider this to be the topmost and this to be the bottommost. Then at the topmost location I have to start filling ones. Initially this entire matrix would be filled up with zeros, so it would contain all zeros. Then what they're asking is that let's say they had given me 0 0 as x and y, so this means 0 0, right? And they have given 2 2 as, let's say, x2 y2, so this is basically 2 2, right? Cool. So now what I need to do for this entire square, I need to fill up all ones. So I can fill up one like this. This is what I need to do. Now would a order of, so let's say the number of queries are m, right? And the size of the matrix is n into n. Now would a order of n into m pass? So n over here is 500, and number of queries I guess is 10 to power 4. Let me cross check. Yeah, number of queries is 10 to power 4. So in that case it would give me a TLE, because it's gonna become 25 into 10 to power 8. That's pretty close to a TLE, I must say. So we can't take risks with that. So what next? So we can definitely use a order of n into m logic over here. So what I can say is that if this is a matrix, okay, give me a second. Yeah, this is a matrix, and you want me to set all the elements from this particular block. Okay, let me change the color of the pencil. Yeah, so from this particular block till this particular block, right? Then what I'll be doing is I'll be setting ones over here, right? And I'll be setting minus ones over here. And then when I have to return the answer, so right now I'm not filled up these values, so these values are unfilled. Also these values actually contain minus 1, rather they should have zeros, right? So what I'll do when I'll return the answer finally after completing all my queries, I'll run through the rows. So I'll do a traversal in a row wise fashion, and I'll increment every index from I. So this is the 0th index, first index, second index, third index. I'll increment every index from 1 to n by its previous index. So what I'll do is that matrix of ij plus equal to matrix of I and the previous index. This would give me a prefix sum. So what would happen is that right now these are all zeros, right? So my final answer when I would be checking it, it would become 1. 0 plus 1 is 1. Now it will say give me this value. It is set to 1, right? So it will give, it will also take this. This already has a minus 1 value. It will say add me to this, and this value would become 0, right? Similarly for this 1 1 1 0 1 1 1 0 1 1 1 0. So yeah, if you pay attention over here, this is what we wanted. So this kind of a thing is definitely possible to do in order of n into m time complexity for the queries, and then I'm using a order of n into n logic at the end to process my matrix and to calculate a prefix sum. So yeah, both of them are doable. So that's what I've done over here. I've taken the y1 x1 values, y2 x2 values. The only reason I got a wrong submission at the first go is that I actually took it like interchangeably. So I took x1 y1 instead of y1 x1, so it failed. Cool enough. So initially I'm taking the values, I'm setting all the values in x1 in x1 itself. I'm incrementing all the values in the first column, right? And then I'm decrementing all the values in the column next to the last column. So the last column is x2. I'm decrementing all the values in x2 plus 1. At the end I'm taking a prefix sum, right? So and then I'm returning a matrix. Initially also all the numbers in the matrix are set to 0. So that's it about this problem. I think this was a very easy one, so you shouldn't have taken long for this. If you still have any doubts, you can let me know. So let's move on to the next. Okay, this is already done. Okay, let's move on to count the number of good subarrays. This was an interesting problem actually. So requires just a bit of maths and observation, but even I messed up. Like it took me some time to get the observation correct. So the problem states that given an integer array nums and an integer k, return the number of good subarrays of nums. A subarray is good if there are at least k pair of indices ij such that I is less than j and array of I is equal to array of j. So how would you do it? So we can say that we will count all the subarrays and then we'll check if it's good or not. Now let's start with the brute force approach itself, or the naive approach. So what we are saying is that we have this kind of array. We can like check for all the subarrays and check if they are good or not. But the number of subarrays in an array can be given by order of n square. So if you're gonna follow this approach, you're gonna get it yearly because your time complexity would be order of n square itself. So this is not gonna work. What else we can do? We can say that if I to j, right, let's call this index I and this index j of this subarray. If I to j is a valid subarray, then this also would be a valid subarray. Like okay, okay, so this also would be a valid subarray. Let's just increase the size of the array a bit, right? So what we can say is that if I to j is a valid subarray, then this also is a valid subarray, this also is a valid subarray, this also is a valid subarray. Is that correct? Because in I to j I'm already having k pairs, the thing I required. So if I'm adding more elements to it or more number of cells to it, contiguous cells, then also the property holds, and these are also valid pairs. So with that, what we can say is that if ij, I2j or j2i is valid, then 0 to j 2i. So 0 to j, basically I'm saying that my j2i is valid, so this is my j2i, right? So whatever elements are before it till 0, so these are elements from 0 to j, these can also be appended to my final answer. I hope that that's making sense. With that observation, what I can say is that I'll set 2 pointers. So this is a 2 pointers question, a typical, not a typical 2 pointers question because it requires some sort of mathematics, but yeah, for the major part of it, it's a 2 pointer question. So what I'll say is that I'll set a j to 0 and I also equal to 0. In my logic, what I'll do is that I'll keep a track of the number of similar elements. So I'll maintain a hash map, let's say. If you're watching this question and you don't have an idea about hash maps or stuff, please don't watch it right now. I'm soon gonna make videos on all of this stuff on the data structures. You can like check the logics from there and then proceed with it. Please don't watch this video if you are a beginner coder, because it requires some concepts like a hash map and 2 pointers. So you should stop watching this video. Cool. So with that, what I can say is that let's say my hash map is named num. So in the num, I'll increment the value or the array I. Right. Then I'll check while this property was holding, while my subarray from I to j, while I to j is valid subarray. Right. I'll keep incrementing j. If I keep incrementing j, what would happen is that now j would come to a position. So this what this would do is j would now become invalid, right? That would mean now j is invalid, so all the elements from 0 to j minus 1, right? And if I'm going up till I would be valid elements, right? So this should be added to my answer because this is a valid subarray. Okay, so this is a valid array or valid subarray. Then all of these are also valid subarrays. Now the number of valid subarrays would be 0 to j minus 1 for the ending point I. So these are j arrays. So 0 to j minus 1 actually has j elements in total. So I'll add j to my answer. That's it for this question. So yeah, it was not that tough, but took take some time to get to it. Okay, so yeah, that's what I'm doing over here. So initially I'm saying that my number of like the n is the number of elements that has been provided to me. MP is the hash map I'm maintaining. So there's something I'm using pairs. There are alternative to it, but pairs just denotes that how many pairs do I have in the current subarray, right? Then I'm using a rest that would contain the result that I'm going to return. Then I'm setting 2 pointers I and j to 0. Then I'm incrementing the current element. I'm incrementing the number of pairs. So the number of pairs would be if I'm able to get an element right now, right? And if I already have, let's say, n elements, then I'll be able to make n minus 1 pairs. I hope that makes sense, because if I already had 2 elements earlier and I attached a new element to it, now from that new element I'll be able to make 2 pairs. I can select any one of those 2 elements that I had before and I can make 2 pairs. So that's why like MP nums I minus 1. If you want it to be more intuitive, you can actually write it over here and you can do this. So this actually means the same thing. Cool. Then I'm checking valids. You can actually remove this for just for some checking. Then I'm saying if my number of pairs is greater than or equal to k, right, then the current array or the current subarray is valid. Let's try to make it invalid. So now I'll be incrementing my j and I'll be incrementing the number of elements that are presently there in my subarray. Also I'll be decrementing the number of elements that are there in my subarray. Also I'll be decrementing the number of pairs that are in my subarray. After that I'll be incrementing the result by whatever elements are to the left of j. as we discussed in the logic, so res plus equal to 1 ll into j. The only reason I'm mentioning 1 ll over here is that I didn't want an overflow. I think it won't even matter because res itself is type of long long, but yeah, it doesn't hurt to do it that way. At the end I'm returning res. So this was the AC summation I used. I hope you were able to understand it. If you have any doubts, the comment section is all yours. Cool, let's move ahead to difference between maximum and minimum price sum. Okay, this was not that hard of a problem, but it was kind of a like medium level problem, I'll say. So what it expects us to do is that we are given a tree. So tree basically is a graph which has no cycles, and it's not a rooted tree. Now what we mean by a rooted tree is that a rooted tree always, when we are gonna do a traversal, we are always gonna start at the root itself, right? So it's unrooted, so we can start our traversal from any node. Now what it expects us to do is that we have to find a traversal, right? And we can calculate some. So for example, if we start at the node 2, then this is a valid traversal. So we can go to 1, then to 3, then to 4, and we have a price associated with each node. So the price of 2 is 7, the price of 1 is 8, the price of 3 is 6, the price of 4 is 10, right? So now this would be the sum of the traversal. So the sum of the traversal over here would be, I guess, they would have mentioned this. Yeah, it's 31. So it's 7 plus 8 is 15, 15 plus 6 is 21, 21 plus 10 is 31. Yeah, so a total of 31 units are being accumulated if we are going through this traversal. Also, what would be the minimum cost of the traversal? So the minimum cost in this traversal is actually true, because we can say that, oh, I'll not traverse anything, I'll just be at 2 itself. So the minimum cost would be 2 only. If that's the case, then what would be the absolute difference of the maximum traversal and the minimum traversal, or the maximum cost of traversal and minimum cost? So over here, if you are traversing through this, you are having a cost of 31. If you were just present over here, didn't traverse anything, then you have a maximum cost of like you have a minimum cost of 2. So we have to return the difference of we have a minimum cost of 7, sorry. So the 2 is the node index and 7 is the price associated with it. So we have to return the difference of them. So we'll return 31 minus 7, that is 24. So that would be the answer. Now we want to maximize this answer. We can start from any node, and we want to maximize this answer. Had we started from 1, what would have been the maximum cost? So let's say had we started from 1, the maximum cost would have been this only, right? This actually makes more sense. So it would have been 6 plus 10 plus 8, that is 16, and 24. In 24, then we'll have to 24 would have been the maximum cost, and then we would have removed 8, so we would have got 16 as the answer. So yeah, this is the question. Now important observation over here, which I actually recently missed or initially missed, and I coded something more complicated, is that all the numbers are positive itself. So over here they have given that the price of I is greater than or equal to 1. So all the numbers are positive. So the minimum cost of any traversal would be not going anywhere. So had you had negative elements, then it would have made sense to perform some kind of a traversal, so as to get the minimum cost, right? Because okay, let's try to understand this with an example. Cool. So let's say this is the area I'm having, this is the tree I'm having, right? This is the node A, it has a value 2, it has a value 1, 6, 5, 9, just random numbers. So at standing at 2, what would be the minimum cost of traversal? If that entire tree has no negative elements, that means if I do any sort of traversal, my value is just going to increase. So the minimum value would be the value at that node itself, right? So that makes sense. What about the maximum value of traversal? So what I can do is I can start at 2. I can check all the values, right? I can check what's the value I'm getting from this node, from this node, from this traversal. I can check all the traversals, and then I can say, okay, so I'll return whatever was the max value starting traversal at 2 minus 2. I hope that makes sense. Minus 2 because the minimum, this is the minimum cost of traversal, minimum cost, and this is the maximum cost of traversal. So my final answer should be max 2 minus min 2, or 2 itself, max traversal of 2. Okay, cool. Now I'll have to perform this operation for all the nodes, as any of the node can be my root vertex. So over here I'll have to perform the operation for all the nodes. So order of n nodes are there. The number of paths are also order of n. For starting at a node, I have n minus 1 edges, right? So the number of paths will also be n minus 1. So so the overall time complexity would become order of n square. That would give me a TLE. Definitely not something I want. How to get rid of it? So we can use DP, right? Now how to use dynamic programming over here? I'll use a hash map, and I can say that okay, so my DP structure would be something like this: DP of node and then previous node. So what this basically means is that what is the maximum sum I can obtain if I'm at a node called node, and the node I'm coming from. So let's say this is the structure I was following. So if I'm coming from 2 to a node called 4, right? What is the maximum value I can get? Now this value would always be unchanged. So let's say I'm coming from 1 to 2 and then to 4, or if I'm coming from 6 to 2 and then to 4, the value of 2 comma 4 or dp2 4 would always be the same. It won't change. The reason for that is there are no cycles in it, so it can't be that it goes back to 6 or something of that sort. So whatever maximum value I can get if I use 2 to 4 is going to be the same. So I'm storing this value in a DP, and that would reduce our computations. Yeah, that's it for this question. So that's all you need to know for this. Let's look at the code. The code is a bit big, not like really big, but yeah, just a bit big. Now over here one thing extra is that you can't take an integer. You have to take a long because they are even expecting the answer in long, and the number of nodes are of the power 10 to power 5. Each of the node can have a value of 10 to power 5 also. So in total it becomes a 10 to power 10. So your integer might overflow. I actually started with the integer, I submitted it and got a WA. Cool. That being said, let's try to look at the code. So initially I'm making an adjacency list. This is basic stuff. If you have worked with graphs, you know this. So I'm not going to explain what the adjacency list is, at least for this question. Then I'm setting a variable res equal to 0. Then what I'm doing is that I've named my function, the traversal function, as tr. You can name it anything. This is not good way to name it, but just in interest of time I did it that way. So then what I'm saying is that if I make I as the root node, what would be the maximum sum path I would be able to get? So that would be written by my function. Then I'll subtract it by the price of I, right? And I'll store this value in rest. So the maximum value would always be in rest. That's what I want, right? Cool. Now let's look at the traversal function. What the traversal function is doing. Now my traversal function is firstly checking that if I already have node and previous in my in the DP array. So this is the DP array I've called sum. You can call it DP or whatever you want. So if it's already present over there, then no need to do all of these computations and increase your time limit or increase the number of computations. So I can directly return it. Right. Else if that's not the case, then I'll set my maximum value as of now to the price node or to the price of that particular node. After that, I'll say that I'll have to traverse through all the elements and then check for the maximum path possible. Now if the current element, the neighbor path or the child path I'm going to is equal to the previous path, then it means I'm going through a cycle. So I want to provide avoid that. So I'm saying a continue over here. So don't traverse it if I'm going to the parent node itself. Cool. After that, I'm checking for the maximum value I'll be able to get if I traverse to the child node, that is denoted by NB. If I do that, I'll be getting a value V, right? Now I have to update my MX. If the path I'm going to is greater than the path or the result I'm having in my variable MX, in that case I'll update it. So what I'll be updating it is with V. So V is the sum path I'll be getting from my child. So V plus the node itself. So initially you are actually starting from the node, right? If you are going from 1 to 2, even the price of 1 would be counted. So I'm adding V to it. So this is making sense. I really hope that. At the end, I'll just return my value mx, and I'll also store it in the DP so that it can be reutilized and I don't have to recompute same things again and again. Yeah, that's it about this. If you want to do some optimization, you can actually do this, but yeah, this is pretty fine. This doesn't gives you a TLE. The time complexity is also order of you can say order of n, because you're actually storing the values over here. Okay, one might ask that you are storing the previous and node pairs, so that might make the order time complexity order of n square. Not actually, because over here the tree, we are talking about a tree, the number of edges in a tree is of the order of n, right? We cannot have more than n minus 1 edges in a tree because there are no cycles. So because of that, the size of this sums array or sums dp is actually limited to order of n itself. If you have any doubts over here, definitely let me know. It was a bit intriguing question, not really tough, but yeah, a bit intriguing for sure. So let me know if you have any doubts. I'll be more than happy to clear them out. Also, I'm starting my new series on data structures and algorithms starting tomorrow. So be sure to check it out if you have not checked it out already. And we can connect on the Discord servers always. Cool guys, thanks a lot for watching this video. I hope you are safe and happy. Keep coding, happy coding. Bye bye.